So in today's demonstration, we're going to do this lab active metals, and here are the ingredients we're going to be using. We're going to use that equipment there, and copper 2 chloride, that is this substance here, and distilled water, which we have in this graduated cylinder, and then also aluminum foil, which has already been cut to size. So the first thing we're going to do is pour the water, 25 milliliters, as you can see, into the beaker. And then we're going to pour the copper 2 chloride, that's this substance, into the water. But before we do that, we want to notice what characteristics it has, because you have a chart in this lab that you have to fill out. And on the chart, you're going to have to list characteristics of the things that you're mixing together. So this is dry copper 2 chloride dihydrate. That's this substance. As you see, it's a really pretty blue-green color, and it's kind of grainy. It looks like sand, doesn't it? So in your lab, you're going to write the description of what it looks like. The next thing you're going to write is, what does it look like when you add the copper 2 chloride to the water? So we're going to do that now. I'm going to try to get it all in there. Okay. So there it's in the beaker. And it doesn't really look, I'm trying to get down there where you can see. You see the water is still water. We'll get this closer. We'll see if it's bubbling or anything. It looks like there's a layer of blue. It looks like it is bubbling. Do you see the bubbles? Right. So on your chart, in this line here, the second line, where it says copper 2 chloride added to the water, you're going to write that you saw the little bit of blue coming up, and we'll go back there again. Hopefully you don't have to tilt your head too much. And you can see the layer of blue, and you can see it's bubbling somewhat in there, not very much. Okay. The next thing you're supposed to do, after you write that down, is you're going to stir up the mixture until you completely dissolve the solid. And after you do that, you're going to take the temperature of the mixture. Okay, so we're going to go ahead and stir it. We're going to use the thermometer to stir it. And right away, you see the color change happening there. You see it's getting that really pretty aqua blue color. So we're stirring and stirring. It looks like there's still some down there. Now, the temperature in this room on this thermometer, this is a Celsius thermometer, and it was about 20 to 22 degrees Celsius before we started. So let's see what the thermometer says now. I've got to move that little thing. I should have moved it before. Okay, somebody put it right in the way. Let's see if I can get my camera to stand up. Okay, yes. So there's that little blue thing that's in the way. So I'm going to try to move it up some. Okay, so if you look at the thermometer now, okay, let's see if we can get it to focus. It doesn't want to focus. Oh, it's focusing on the thing behind it. All right, well, I'll read the thermometer for you. It says about 23 degrees Celsius, okay? So that's pretty much close to the starting temperature. It's maybe a degree warmer. The next thing we're going to do, all right, so, and again, you're going to write that starting temperature going back to your chart. You see it says initial temperature of solution. So, by the way, you notice above that, copper 2 chloride stirred in the water. That's where you're going to write down that it turned blue. Also, you'll notice that it pretty much all dissolved in there, and now we have this really pretty blue-green solution. You can see there's no more solid in there. So we record that in the chart, and then we also record that temperature. That we're calling that the initial temperature of the solution, because that's the temperature of the solution before we add the second ingredient. So far what we have is water, distilled water, with this copper 2 chloride in it. The reason why we use distilled water is because tap water, just regular water out of your sink, has minerals dissolved in it, minerals being metals. And it's possible that they could interfere with the results of this experiment. So that's why we're using distilled water, or it's also called deionized water. It has the minerals removed from it. Okay, now the last ingredient we have is this piece of aluminum foil, which is 8 by 8 centimeters. We're gonna crumple it up. We don't wanna crumple it up too much. And we're going to add that to the solution. Now, once we add it, a lot of things are going to happen. So I'm going to have you notice on the chart, there's a place for you to write copper 2 chloride solution plus aluminum foil ball. And when you get there, you notice there's a space here. A lot of things are going to happen. So you might want to have to play this video back again to see all the different things that are going to happen. And one of the things we want to notice is, what does the temperature do? And that's why the thermometer is there. I'm going to turn this a little bit so that that white label's not in the way and you can see better what's going to happen. We want to try to notice how high the thermometer goes. So I'm going to put this down. So, and then I'm going to use the thermometer to stir it with, and I'm going to keep an eye on the temperature. But I also want you to notice what's going on in the beaker. Oh, that's a little problem. I need to tilt it so you can see what's going on in the beaker. Yeah, I have to do it like that. Okay, so I'll keep an eye on the thermometer and the beaker at the same time. Okay, here goes the aluminum foil in, and I'm stirring it, okay? All right, do you see anything happening? Yes. You might even be able to hear it. Can you hear the bubbling? Oh, yeah. And what's happening to the foil? The foil's breaking apart. And you see there's steam coming out? What's the thermometer doing? Take a look at it. It's going up. You can't read it again. It's not focusing. It's already gone up above 40 degrees. And you see what's happening to the aluminum foil? It's breaking down. I mean, there's so much steam in there that it's fogging up the beaker. The temperature's up above 60 degrees now. You can see what it looks like down in there. Almost all the foil is gone. Look, it's changed color. Also notice that the liquid has changed color as well. So we're stirring that. The temperature is up about 61 degrees. Oh, it focused for a minute there. Amazing. Oh, there it is. Yeah. So I'm going to keep stirring because I think there's still a little bit of the foil left. Not really. Also, you can't tell, so I'll tell you. But when it was making all these other reactions happening, there was an interesting smell that we smelled. It was kind of odd. So now the lab asks us to wait about 10 minutes and see what temperature the thermometer is going to go down to. I'm not going to wait the 10 minutes because I already know what it's going to go down to. I did this experiment yesterday. And after you let it sit in there for a while, it drops. Now, if you want to see that, you can see I stopped stirring and look, it's already dropped down below 55, and it's just going to keep dropping. While we're watching it go down a little bit, I'll check back occasionally and let you see. I want to point out that there's an equation in your questions, and here's the equation. And you notice the equation says copper 2 chloride aqueous plus aluminum solid yields copper solid plus aluminum chloride aqueous. What does aqueous mean? Well, that means that we took a solid and we dissolved it in water. And you remember we took the copper 2 chloride, that was the green, grainy looking sand-like material, and we dissolved it in water. And then we added a solid aluminum, that was the foil. And they made a chemical reaction, and you definitely saw that there were signs of a chemical reaction. In your notes today, we had the signs of a chemical reaction, and there's quite a few, so I'm going to list them here. So one sign of a chemical reaction is that you make a new substance, and that's the most obvious one. Another sign is that there's a temperature change. Now, you definitely saw the temperature change. Another sign is a release of a gas. We may or may not have seen a gas. At the very beginning, when we put the copper 2 chloride into the beaker, we saw some little bubbles at the bottom, but the steam that you saw coming out of here isn't a gas. That was actually the water in the beaker boiling from the heat, because you saw it was steam and it fogged up the sides, remember? Another sign of a chemical reaction happening is if you see a color change, and we very definitely saw more than one color change happening in this experiment. Also, a change in smell is a sign of a chemical reaction. So we had that as well. In some chemical reactions, they also give off a light or sound. We didn't have that in this one, but you could have. So that's quite a few things, and pretty much everything on that list happened in this experiment. Okay. So let's go ahead and check and see where the temperature is now. Let's see if you can see it, if it's going to let us focus. Oh, that's better. Look, it's almost down to 40 now. It's gone down another 10 degrees in the last couple of minutes that I was talking. If I wait another few minutes, it'll get down below 30. It won't get all the way back down to like 20 or 22 until we're finished. Now, there's one more thing I need to show you in this demonstration, and that is what's left in the beaker. I'm going to go ahead and take the thermometer out now because we don't need to take the temperature anymore. And I want you to see that the liquid inside is of kind of a brownish green, but there's not just liquid in there. I'm going to tilt it so you can see. Look at that. See that kind of reddish, sandy stuff down at the bottom? Let me see if I can show you from the side. Can you see it at the bottom? In chemistry, when you mix things together and you get a solid form, that's called a precipitate. Okay? So there's something solid at the bottom of this beaker, and it's a different color too. It is definitely not the color of the copper 2 chloride. So in your chart where you list your observations of what you saw, you should list also that you ended up with 2 new looking things at the end of this lab. We have this greenish blue liquid, and we have the copper. We have that, and I just gave it away. That is the copper you're looking at, folks. Let's go back to the equation so you can see that. So we started with the copper 2 chloride, which was the green sandy looking stuff, aqueous. We put it in water, and then we put in the aluminum foil, the solid aluminum foil, and then the reaction happened, and we ended up with copper, solid copper. Well, the only thing solid in here is that stuff at the bottom. That must be the copper. And it is kind of a coppery color, isn't it? And then the other thing that's left is aluminum chloride aqueous. So in that liquid, that greenish brown liquid, that's the aluminum chloride, because that's the only thing it can be. That's the only thing that's left. Okay? So now that we've covered all that material, it's up to you to finish answering the questions for this lab. And I hope you enjoyed this demonstration of a chemical reaction.